morning to all of you. So today I will discuss resonance and bond order. Okay, then I will discuss uh, Huygens rule and hydrogen bonding. Okay, so the formula of bond order from resonance is equal to number of bonds by number of resonance structure. Okay, so at first you have to draw the resonance structure, then calculate the bond order. Okay, so for CO3 there are three resonance structure. Let's see the three resonance structure. This is resonance hybrid. Okay, so bond order is equal to, there are four bonds. Okay, and three resonance structure are there, so 4 by 3, that is 1.33. Okay, next pu4 3 minus, for pu4 3 minus there are four resonating structure, and so bond order is 5 by 4. There are 5 bond. Okay, so 5 by 4 is equal to 1.25. Next O3, for O3 molecule, that is there are 3 bond are there and 2 resonating structure are there, so bond order is 3 by 2. For NO3 molecule there are 3 resonating structure and 4 bonds are there, so bond order is equal to 4 by 3. Okay, so next hydrogen bonding. Okay, so we know that hydrogen bonding is formed between when hydrogen atom is attached to electronegative atoms like fluorine, oxygen, nitrogen, then a partial negative charge is developed. Okay, on electronegative atom there is negative charge, and for electropositive atom, that is for hydrogen, there are develops electropositive charge, delta positive charge. Okay, so resulting a dipole, and if there are more than 2 or 3 molecules, then one weak interactions are there for fluorine atom, or you can see that is electronegative atom and hydrogen, and this is called hydrogen bonding. Okay, so next hydrogen bonding is two types. There is intermolecular hydrogen bonding and intramolecular hydrogen bonding. Basically intermolecular hydrogen bonding is very important for you exam point of view. And for intermolecular hydrogen bonding, this is present between 2 or more molecules which may be same or different. Okay, but intramolecular hydrogen bonding is generally observed in the organic molecule basically, so it is shown in the same molecule. Okay, next intermolecular hydrogen bonding. Basically I will discuss all about intermolecular hydrogen bonding because in inorganic chemistry this will be very much applicable. Okay, intermolecular hydrogen bonding, the conditions are there. Hydrogen must be attached to highly electronegative atom, that is fluorine, oxygen or nitrogen, and size of electronegative atom must be small. Okay, and you can say that electronegativity of this fluorine, oxygen or nitrogen, that is electronegative atoms, is greater than equal to 3. Okay, then intermolecular hydrogen bonding is observed. So fluorine is most electronegative hydrogen electronegative atom, then oxygen, then nitrogen. So HF bond is more polar, you can say, or then HO, then HF. Okay, next application. What is the application of this intermolecular hydrogen bonding? At first you can say physical state. For intermolecular hydrogen bonding, for water or HF, you can say that is they are liquid. Okay, but H2S and HCl, this is a gas, because there is no intermolecular hydrogen bonding. Next, acetone is liquid while urea is solid, because in case of urea, the structure of urea is CONH2 whole 2, that is this type of structure there. So there is intermolecular hydrogen bonding is occur. Okay, but in acetone there is no. So this is liquid. Okay, next molecular weight. Molecular weight of acetic acid is 120 instead of 60, because due to intermolecular hydrogen bonding, acetic acid is formed as a dimer. Okay, next solubility. Hydrogen bonding, if we say that hydrogen bonding is increases, then solubility also increases. Okay, alcohols are more soluble in water than ethers, because alcohol form hydrogen bonding. Okay, so you can see the structure of this water molecule is attached to alcohol, and you can form that hydrogen bonding is there. Okay, next parahydroxy benzaldehyde or nitrophenol are soluble in water due to intermolecular hydrogen bonding. Next, melting point or boiling point. Melting point and boiling point also increases due to intermolecular hydrogen bonding. So water have greater uh, boiling point or melting point than methanol, then ethanol. Okay. Next, viscosity. Viscosity also is proportional to hydrogen bonding. So glycerol is more viscous than methanol. Okay. Next, ionic bond or electrovalent bond. It is very much important from your exam point of view. Uh, it is the electrostatic force of attraction between cations and anions, and here electropositive atoms and electronegative atoms are there, and ionic bond is formed. Okay. Electropositive atoms are generally metal, and electronegative bonds atoms are generally non-metals. Okay. It is a non-directional. Next, if ionic bond is formed, then what are the major steps? Okay. So at first metal is solid state to gaseous state form. Okay. Then metal is gaseous state to cation is formed. If we say that non-metals are there, then at first non-metals are non-metals are dissociate into its atoms, then it accept an electron and gaseous anion is formed. Okay. Then metal cation and non-metal anion is combined to each other and form an ionic compound. Okay. So the terms are, that is lattice energy, that is electron affinity. Okay. And these are ionization potential, bond dissociation energy. So this is the term of, this is absorbed energy. Okay. And this is the release energy. Okay. Next, lattice energy. What is lattice energy? It is the amount of energy released when 1 mole anionic crystal is formed from its gaseous constituents. Okay. So the formula of lattice energy is proportional to Q1 by Q2 by R square. Okay. So here you can say that LiCl is have more lattice energy than CaCl. Okay. Next, Born-Haber cycle. This is very much important in your exam, because this topic is highlighted in the syllabus. So Na plus sodium plus half Cl2 to form NaCl. Okay. So how this will be the process? Okay. At first, sodium solid to form sodium gaseous. It is delta H sublimation. Okay. This is positive. Next, sodium gaseous state forms Na plus cation. Okay. This is ionization potential or ionization energy. It is also positive. Next, Cl2, this molecule is breakdown, that this bond dissociation energy, it is also positive to chlorine atom. This is gaseous molecule. Next, gaseous Cl to form gaseous anion, Cl minus gaseous. Okay. So this is electron affinity. This is negative. Okay. So then Na plus and Cl minus will attached and NaCl is formed. Okay. And this is lattice energy. This is also negative. So delta H formation of NaCl is equal to delta H sublimation plus ionization energy plus bond dissociation energy by half, as there is half Cl2. Okay. Minus electron affinity and minus lattice energy. Okay. So this will be the delta H formation. You can from this you can calculate lattice energy. Okay. If all the values are given in the reaction sequence. Okay. So this is very important. Next, I will discuss Fajans rule. Okay. It is very important. Basically, covalent character is developed in ionic bond. It is explained by Fajans rule. Okay. So what is the, at first we know that what is the polarization or polarizing power. Okay. So it is ability of a cation to polarize an anion, or you can say that deformation of anion by cation. Okay. Next, polarizability, the ability of anion to get polarized. It is polarizability. So factors affecting polarizations are, at first, size of cation. As the size of cation decreases, polarization increases. So covalent character also increases. Okay. You can remember this: cation size decreases, polarization increases, and covalent character increases. Okay, next this is the examples of this. Okay, next, size of anion. Size of anion increases, polarization increases, covalent character also increases. Okay, so for anion, for case of anion, more the size of the anion, covalent character increases. For cation, less the size of cation, covalent character increases. Okay, next, charge of cation or anion. Covalent character is proportional to polarization, is proportional to charge on cation. Okay, and charge on anion. Okay, so this is the topics. Basically the chapter is overall completed. Okay, next in the next class I will discuss some MCQ from this chapter.